Assalamualaikum warahmatullahi wabarakatuh. Very good day to Dr.Siti, Zubaidah, Binti, Ismail and everyone. So our team will be presenting about the production operational planning for our product, which is for flexible LED lights mini USB fan. So together with me, Hidayah Binti Muhammad Nizam, and my team members, Nurain Binti Masri, Nurul Aziera Binti Mahadi, and Siti Darwisyah Binti Azian Kamarudin. Okay, next for the organization chart, I'm the manager, Hidayah, followed by secretary, Siti Darwisyah, production executive, Nurain, and marketing executive, Nurul Aziera.
So for introduction, production planning. Planning of production and manufacturing system of an organization or industry. So basically our product is flexible LED light mini USB fan. Operational planning helps in planning business strategy, analyze design, and manage the production system. Also, it is determining the cost and the revenue of the product. So for background of study, this mini fan is just the thing for keeping cool on the go. It plugs into any USB port, meaning it is portable and practical. Next, the sinusoidal neck design. It is feel free to adjust the position and direction. It is portable, compact, and also easy to carry. Next is it has high efficiency power saving, which is 5 volt more to consume the least amount of electricity. The USB interface fan provides strong and stable for you. And this mini fan also no need battery.
Next is the methodology of the product tree structure. The flexible LED light mini USB fan product tree structure provide a hierarchy classification of the item which form a product. So the main product here we have flexible LED light mini USB fan, and under that we have three separate parts, which is silicone blade propeller, flexible alloy handle assembly, and USB head. Under silicone blade, we have LED light chip, and under flexible alloy handle assembly, we have cable and also small motor. So as you can see, we have three type of level, which is level 0, level 1, and level 2. Level 0 shows the independent demand, and level 1 shows the dependent demand. And once the independent demand is known, we can determine the dependent demand. Next is the methodology of the BOM list, which is the price list of every part. Here we have silicone blade propeller, LED light chip, flexible alloy handle, cable or wire, small motor, and USB head. So the total cost of this part is RM25.20.
Okay, next for the methodology for break-even analysis. So basically, break-even analysis is like to determine the number of sale that we need to know in order to cover up the total cost of fixed cost and variable cost. So to know the break-even analysis, we need to have a fixed cost, a variable cost, as well as the price per unit for a product. So in this case, for our product, for the fixed cost, our total cost for the fixed cost per year is 72,000 ringgit Malaysia. The total cost for the variable cost is 29 ringgit 20 cent. So for the price per unit for our product is 45 ringgit. And for the break-even analysis, how to calculate the break-even analysis, we just basically need to divide the fixed cost by price per unit minus by variable cost. So as you can see here, the break-even analysis for 1 year is 4,557 unit. So in order to cover up the whole year of the fixed cost and the variable cost, we need to have 4,557 unit. So this is only for 1 year. For in 3 years times, we need to times the break-even of 1 year by 3. So basically this is the break-even for the in 3 years times, which is 13,671 unit for break-even analysis. Okay, next for the methodology of manpower scheduling. So for our business, all of our 5 employees will have 2 days off, and the other days will be take off.
Assalamualaikum. I will present my part material requirement planning. So our final product is flexible LED light mini USB fan. So the given is demand annual. Our annual demand is 4,740 and cost ordering RM 516 and cost carrying RM1. So for L4L, LLC is 2 and lead time is 1. So as we can see, course requirement we'll get the same result as net requirement. So before proceed to do EOQ and POQ, we should do the calculations for QOP. So for the calculation QOP, the formula is 2 times cost ordering times demand divide cost carrying and times 0.5. So means 2 times 560 times 393 per 1 times 0.1. So we will get 663 ringgit. For POQ, so the total of EOQ divide demand, so we will get 2. When we get all of the final answer, so we can proceed to EOQ. As you can see, the different on project on hands and planning order receipt. So this is the result. And so for the MRP POQ, we will get this result for POQ after we do the calculations. And lastly, for total cost, we do the formula using this formula. Number of order times cost ordering plus total project on hand times cost carry. So for total cost L4L, we get 6,172 ringgit. For EOQ, 5,990 ringgit. And lastly, POQ will get 5,479 ringgit. So that's all for my presentation.
Okay, so for the economic order quantity, basically economic order quantity is the optimal order quantity that a company should purchase in order to minimize the inventory costs, such as holding costs, shortage costs, and order costs. So for our product, knowing that the annual demand that is the same from the annual demand from the previous MRP, which is 4,714 units, and our ordering cost is 560 ringgit, carrying cost 1 ringgit. We calculated our Q optimum and we obtained 2,298 units for our EOQ for the whole product. Okay, for the conclusion, after comparing the 3 of the method in the MRP, material requirement planning, so POQ method should be chosen, since that the total cost for the POQ, which is 5,479 ringgit, and it's the least total cost other than those two, which is total cost for EOQ 5,990 ringgit, and total cost for L4L 6,172 ringgit. So POQ is chosen. So in order to minimize the inventory cost, 2,298 units of product is the optimal order amount to be purchased by our company in order to not having an excessive inventory in the future. So